Assalamualaikum everyone. Selamat pagi. Good morning. So I am Hariri from University Kebangsaan Malaysia. Today I will present to you in SGP 2020 with topic multiple application of near surface geophysical survey in Malaysia. Some case studies. Okay, we have around 30 slide. So the summary of slide is we try to discuss about the near surface investigation using resistivity and maybe some IP method. So then I will share with you about 4 main application. Number 1, investigation of contamination site. Then number 2, settlement area, especially on housing area. Then we have cavity detection, and last some cases at slope stability or tunnel stability study. Okay, because we discussed about the near surface, how we can interpret or how we can say about the near surface, how near actually. So certain result can be present maybe 6 meter, 50 meter, as shown in this figure. So it's depend on how long you lay out the cable, because normally for resistivity methods we can get deeper information based on how long we lay the cable. So let's say this one we lay the cable around 40 meter and then you get 6 meter, and then the second one you get 50 meter. And then next we have different total length of straight line. So you can get maybe 30 meter, and also you can get 150 meter. Okay, this one yeah, very nice result last time on my PhD study leave. My team conduct the survey for detect the fracture system at the air hangat hot spring. So you can see the clear of fracture zone, and then the blue color may be representative of saltwater intrusion at the air hangat. And then I like to share, so this zone may be intermediate value of resistivity, maybe the cap layer from the silt and clay. And then we have some theory about why the temperature at air hangat now become cooler compared to the previous time. Okay, and then maybe we also can have up to 300 meter depth based on the longest cable that available in the market. Based on my experience, we have 800 meter. So using pole dipole array, you can get up to 300 meter here. So this one maybe your interest in maybe geothermal system, maybe on mineral exploration, something like that. So it's depend on your design of survey. So longest you lay the cable, and then you will get the deeper information. Okay, let's start with the first example of contaminated site. So we have this on the left section. if I'm not mistaken, this is somewhere at Gombak. So we use a very close spacing actually here. If you can see here, the total length of survey line is around 20 meter, so you will get the information around 5 meter only. So the objective here, we want to study about the contaminated site based on what they call it, oil or grease from transformer. So this is another site at the Mersing. So you can see here the dark color is oil. So we use the resistivity method to study the thickness of layer with soil. Next we have somewhere in Penang, and then this one also maybe from Teluk Intan. So basically we have site that have a transformer leak from soil with the oil. So we use the resistivity method with the close spacing to see the thickness of contaminated layer. Okay, so can you imagine this is a store where they put the transformer, and then the oil leakage to the surface, and geophysicists can help them to look the thickness of oil that already contaminated in the soil. This is another site that contaminated. So we lay out the cable. I think this is from TI, maybe from Teluk Intan. I cannot give the specific name because this is a sensitive area actually. So they use the trial pit to see the profile. So I try to zoom. This is what they call it, oil layer. At the top they have premix, they have clay material, and then the water level there, you can see the oily the water with the oil. Okay, maybe I discuss a little bit about this result. So we have 1 2 3 4 5. So what I want to say here, at the top you can see the profile with very high resistivity value compared to the bottom part. So last time, based on this what they call it, trial pit, so we interpret the resistivity value with the height value representative the oil layer. Okay, and then based on the resistivity result also, we can get some information where is the water table. So basically the oil layer will not intrude to the water table. So this method for me is very useful. You can identify the thickness of contaminated layer, and then where is the water table. Okay, next, okay, this one I'd like to share the new paper that my team published basically a few weeks ago. You can go to this website, and then you can read the full paper. So we use a resistivity method, and then we use Oasis montage to generate 3D model, which is we try to calculate the contamination soil volume. Okay, so you can read the detail of this paper based on this website link. Okay, this is some result that I like to share today. So you can see very clear the low resistivity value representative of soft layer. Here we interpret like that. In bracket we put as waste material. So at the side you can see all the waste material is dumped here, and then maybe the site have a very high water content, so that's why it's contribute the low resistivity here. Okay, same goes to the center, and then on the right section the thickness of waste material can be identified using this method. So based on that we can know the volume. All right. Okay, this is summary for this site at Kapon last time. So we have around 6 survey line, and then you can see at the top we have soft layer, which is we interpret as waste material, and then we have intermediate resistivity value with the green yellowish color, and then the high resistivity with the reddish color. So we try to produce the fence diagram to try to calculate the volume of contaminated soil layer, and then later based on single 2D result we have 6 line, and then we produce the fence diagram. So at the end we try to establish 3D model. So based on we have width, we have length, we have depth. So this result will help us to calculate the volume. Okay, so we can estimate the soil volume based on this resistivity method. So you can read detail of that case on my previous slide. Okay, next we have several example for soil settlement. Yeah, sorry, minta maaf, the 2D result here which interpreted what we call it interpreted part with the Malay language. So this is what they call it sinkhole. So the house collapsed in the last time in the Deepavali day, I think 2012 2013, something like that, somewhere in Ipoh. So we use the resistivity method to map where is the lubang benam or sinkhole. All right, and then maybe based on this result also you can see the channel where the cavity occurring beneath the surface. All right, so the high resistivity value, maybe this one is solid bedrock. Maybe here not so accurate, the interpretation put here is bongkah batuan. I think maybe it could be the solid bedrock here. Right. Another example for soil settlement, this site somewhere in Ipoh also, I think on Pengkalan area. So after they embark the flat area here, and then they start to piling, and then maybe after heavy rain, so you can see here the pillar is collapsed. So we try to help this engineer. So as a geologist or geophysicist, we can identify the soil profile here, the thickness of embankment, and then maybe from that we can advise them the where is the compact layer. So maybe here they need to pile maybe based on this depth, So you can advise them the thickness of soft material or loose layer, and then engineer need to make sure that the piling here is good enough, set on the hard layer. And then this is one of example for soil settlement somewhere in Kampa housing area. Okay, you can see this already what they call it, pecah or broken here. And then this is the main hall, or what they call it, ruang tamu. So you can see the shape of this tile almost boom. All right, so maybe we can advise them to move to another house lah. Okay, so I use the resistivity method also last time. Here you can see we drill the tile and then we put the electrode and then we start the measurement. Same goes to this side. You can see this is the empty space, and then we drill and then put all the electrode there to get the void area for this settlement problem. And then yeah, maybe this one I can share some result, resistivity and IP. I try to gain as much as I can to understand the result of IP, the weakness, or maybe the positive and negative aspect when we measure the resistivity and IP together. So at the housing area at the somewhere in Kampar, so we want to know the settlement area. So based on my experience, normally the void with the empty space not filled with water, normally they will give us high resistivity value. As you can see at the surface, normally high resistivity value, normally the area is have a problem. So you can see also on line number 2, 3 and 4, if we have maybe what we call it low resistivity value, maybe the area have a lot of water. So for soil settlement, based on my experience that I can share with you audience today, the changing of water level can cause more serious condition of settlement. So based on resistivity anomaly, you can see the soil profile, where is the settlement area, where is the void, where is the saturated zone, something like that. So based on that, we can know we can get some idea to advise house owner, can advise majlis daerah, something like that. Okay, and then I like to share the another case for cavity detection. Here is Bandar Baru Kampa, which is terminal bus here. Okay, so last time I went there with my professor, and then with our student to look fossil actually. But I want to share with you because last time I also involved to study the soil and rock profile here. So this pinnacle hopefully can what we call it capture in resistivity profile. So for near surface case study that I like to share here is something like this lah. So relate to this pinnacle occurrence. So of course engineer will face some problem here when they try to put the piling. So for this site, last time they built the terminal bus here. So if you can imagine this site with this kind of profile of hard layer, rock profile with this kind of pinnacle. So we hope that resistivity method can help us to map the profile. Okay, this is beneath the Bandar Baru bus station. So we really happy when we get this result. So after we process the data, we we can confirm the result after they conduct several borehole. Here you have we have some borehole location, so we can interpret the result based on borehole data. And then if you can see, let's say this one, you have maybe floater here, some anomaly with the high resistivity value, and then beneath here look like solid bedrock of limestone here. Every survey line at a certain depth, we can see the what we call it very solid bedrock. But here you can see the profile is undulating, so maybe representative of the pinnacle of limestone beneath the surface here. For me it's very clear. Maybe after they remove several meter of topsoil, and then you can find the pinnacle of limestone. So this is very useful to engineer, to help them to get some idea how they can set the piling to the hard layer. And then next we have case for landslide. My team involved for what they call it Gunung Pas area. So here is a schist that keep fill before now. I think they already finished develop tunnel. So this residual material from landslide can what they call it flow on the top of tunnel. Okay, before this we don't have tunnel here. So after JKR develop tunnel, so all the vehicle can pass through this site using the tunnel. Okay, so we use the resistivity method. You can see the profile based on the actual topography. Here is at the bottom of main road, and then we climb with our team, bring all the equipment, battery, resistivity meter, and another set of equipment. So we plot, and then we can identify where is the what we call it maybe the water containing zone, which is maybe contribute to the failure of this slope. Okay, and then maybe based on this result we interpret last time maybe the fault, where is the fault plane, where is the fresh bedrock here. So based on that, maybe we can see all the material actually look like highly fractured, and then that's why this side keep fill. Okay, and then we have another site at the Palembang Tompat. So we can use actually the resistivity method to find the archaeology site. So first photo here show the maybe port ataupun apa pelabuhan. Okay, on this photo, after we finish the processing data, we interpret, and then we believe at this side we can identify the tunnel direction. And then this photo show actually what they call it, army zone here. So we have army to identify. Here they have a lot of bomb mortar here, so army already confirmed, and then we need to identify the tunnel direction. Maybe Japanese put the bomb here to make sure anyone that try to get the gold from Yamashita maybe. So we have a lot of people here last time, especially army section here. Okay, next we have another story about archaeology. So last time Mr. Rahim from JMG and me, that time we are master classmates, so we have Professor Rahim to map the tunnel at Setiu. You can read the full paper here at the Science Malaysia website, where we try to identify this is they already Japanese already plot the direction of tunnel on top of fresh rock. So based on this, we lay out the cable and try to map the tunnel. And then this is a photo show about the one of box that already stolen. So not sure lah siapa dah curi harta karun. So and then this example of material inside the box we found last time. Okay, this is example. Sorry, it's again in Malay. So we interpret last time where is the bongkah batu, where is the tunnel with the highly water content, and then where is the fresh rock, where we believe the tunnel is developed under this fresh area. So yeah, the client is very happy last time. Unfortunately, we cannot join them after we show the location of possible of tunnel. So that client asked me to, okay, Hariri, you can go back. So I don't know what happened. Maybe they already got the gold bar maybe. Okay, next this is example of tunnel stability study. So if you can see here, we lay out the cable on the crown of tunnel, and then this one we drill the what we call it, left and right side of tunnel in this area. So we try to look where is the high water content that we can relate with the maybe not so stable area. So we use resistivity method last time to help engineer to design tunnel stability method lah. Okay, and then this is another example for pavement area somewhere in KL. So they detect the cavity, and then it's happened because of pipe pecah last time. And then this is a photo that show we need to drill somewhere at the back of house, which is pavement area. So yeah, basically the resistivity method, we need to put the electrodes. So if you deal with the pavement area, so you need to remove this brick, and then sometimes you need to bring the genset together with the drill machine lah. And then so some example of photo, we use a resistivity method for hazard zone. I think somewhere in Shah Alam last time. So beneath the Pansapuri, so semua sudah kosong kat sini kalau tengok. And then this is a parking area already damaged. and then some part of area covered by this sheet to avoid the what they call it, problem area. So we lay out the cable using small spacing to make sure we get detailed information to map the hazard zone. And then yeah, the pit area also for near surface, because normally in Malaysia, based on my experience, the peak thickness normally less than 10 meter, so you can use the resistivity method to identify the thickness of pit. So I involved last time with several projects related to the identification of pit thickness. Of course, we try to have fireman last time to padamkan kebakaran. Okay, so this is another application lah. For actually for tunnel stability rating system related to the my previous slide, we try to look for tunnel stability system. So if you're interested to read more detail about this classification system, you can read at the ResearchGate page. Okay, so last time I used resistivity and GPR to map the unstable area. Okay, so this is example again, side photo. We use cranes skylift to drill top of tunnel at the crown area, so very challenging last time. And then this is the left side of tunnel. We try to identify the stability of this tunnel, and then we put the GPR to correlate with the resistivity result, and then we try to establish the correlation among resistivity and GPR result. Okay, this one you can see very clear here, near surface result using resistivity method to map the tunnel stability. The bedrock is very clear, solid bedrock, and then suddenly you have low resistivity anomaly, maybe fault that dry. If saturated with water, maybe blue color, which is normally related to the very low resistivity value. Okay, and then this is an example of GPR method last time. Honestly, I'm not familiar with the GPR, but we combine with our team from Nuclear Malaysia, Dr. Azmi last time. So we try to relate the GPR and resistivity method lah. Okay, I think already more than 30 minutes now. So I'd like to say thank you, terima kasih semua. Maybe some slide not explain well or elaborate well, so you can contact me at my email or phone number. And then if you like to read detail about my work, you can search at ResearchGate and also on my YouTube channel to look how we conduct the survey, especially on contaminated area. Okay, thank you everyone. Actually today is quite tired. I like to mention about my cousin, the late Muhammad Irfan Fikri, the pilot that died on helicopter crash yesterday. So today I joined my family to visit that cousin. So Al-Fatihah dibaca, kita sedekahkan kepada arwah, insyaAllah. So thank you, jumpa lagi.